In this video, we'll be learning more about decimals and really focusing on decimal place value. All right, so let's just start by reviewing in fourth grade what we learned about decimals. When we are talking about decimals, we are talking about part of a whole. So decimals are just like fractions in that it is a part of a whole. So when we're thinking about decimals, if this is our whole and this is the part, this red one is the part we're looking at, we would say this is 1 out of 10 equal pieces that would fit within the whole. And so there would be 1/10, 2/10, 3/10, 4/10, 5/10, which you can see 5/10 is also half of the whole. 6/10, 7/10, 8/10, 9/10, and 10/10. So when we look at this part, we're saying that this is 1/10 of the whole, okay? And the yellow flat being the whole. So 1/10 as a fraction, or 0.1, which is the decimal, 1/10. And if we look at that in words, you'll remember last year how I stressed really enunciating that THS, tenths. So 1/10, and it wouldn't be 1/10, it would be 1/10. So these are tenths. So we've talked about tenths. Now, if this is our whole, and we're looking at one individual cube, okay, so that is 1 out of, there's 100 on this flat, so that would represent 1/100th. And we could say here's 200ths, 300ths, 400ths, 500ths, 600ths, 700ths, 800ths, 900ths, 1000ths. And there would be 100 of those little cubes that cover the whole. And that is why one of the cubes could represent 1/100th, covers 1 out of 100, which is also the decimal 0.01, 100th. And again, the word hundredth, enunciating that TH, or hundredths, enunciating that THS. So we really hear hundredths, very different than hundreds. So that's why you have to really enunciate that THS. So hundredths, we have 1/100th. We can see that tenths, here's a tenth, tenths are bigger than hundredths. So last year in fourth grade, we really focused on tenths and hundredths. But this year, as big fifth graders, we're going to look at thousandths. So knowing the size of a tenth, I'm going to grab my pen here. Here's a tenth. Here's 1/100th. Try to visualize what a thousandth, what thousandths or 1,000th would look like. Okay, so one of the first tasks we want to talk about is showing thousandths on a number line as part of a model or in a place value chart. So let's start by looking at this little diagram up here. I think this really clearly illustrates how teeny tiny a thousandth is. So if we look at this first number line, we can see here's 0 and here's 1. And so between 0 and 1, it has been divided into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equal parts. And so this would represent 1/10. And so what they're trying to show you here is that there would be 10 little tick marks between there and this very first one. If we take that between 0 and that very first tick mark and divide it into 10 pieces, that's going to represent 1/100th. And then if we take this little piece between 0 and that first tick mark and divide it into 10 equal pieces, that would represent 1/1000th. Now, that might even still be a little bit hard to visualize, but let's look at this piece down here. Remember how we were saying that that this flat was our whole, and that this long would represent 1/10. This would represent 1/100th. Well, if we took 10 of these and piled them up on top of each other and made a cube, which is essentially what this is, right? It is 10 high. Then one of those, out of that cube of 1,000, there would be 1,000 little cubes built up in there. One of those little cubes would be equivalent to 1/1000th. So this then would be our whole, the cube, and we're looking at that one teeny tiny cube. So that would represent what 1,000th would look like compared to a 100th and a 10th. So let's look. Here are a few models we can look at and practice seeing what these thousandths look like. So again, the cube is our whole, and you can see we have two small cubes colored in, and so that two that are shaded in are represented in our numerator, and the whole is our denominator, the 1,000. So we can see that we have 2 thousandths written in words, and as a decimal would be 0.002. If we have our whole, which is 1,000, and we have these 3 small cubes colored in, that's our numerator, we have 3 thousandths, or 0.003. And on this last one, if we have 4 thousandths shaded in, that would represent 0.004. Now, in looking at decimals on a place value chart, if this is ones place, here's our decimal point. The first place value after the decimal point is the tenths, then we have the hundredths, and then we have the thousandths. So you can see as we move to the right of the decimal point, the size gets smaller and smaller and smaller. So if we had 6 thousandths, that would be 0.06. There are no tenths, there are no hundredths, but there are 6 thousandths. Again, down here, if we have 8 thousandths, we have 0 tenths, 0 hundredths, but 8 thousandths. So how many cubes should be shaded to show each decimal? If we are looking at 5 thousandths, think in your head how many you'd need to shade. And let's do 1, 2, 3, 4, 5. That's what 5 thousandths would look like. And if we wanted to show the decimal 8 thousandths, we would need to shade 1, 2, 3, 4, 5, 6, 7, 8. 8 thousandths. That's what 8 thousandths would look like. And now let's write these on a place value chart. So if we had 7 thousandths, we know here's the ones place, our decimal point, and then the first place value after the decimal point is tenths, then hundredths, then thousandths. So we know we don't have any tenths, so we would leave that blank, no hundredths, but we have 7 thousandths. So 1, 2, 3, 4, 5, 6, 7. That would represent 7 thousandths. And if we had 9 thousandths, again, the decimal point, no tenths, no hundredths, but we have 9 hundredths. There's our 900ths. So now that we've talked about what a thousandth looks like and how we can visualize that with a model and visualize it also with a place value chart, now I want to talk a little bit about how place value works with decimals. Just like with whole numbers, our tens place can fill up to 10. When it gets up to 10 tens, we have to regroup and those 10 tens become 100. Once we get 10 hundreds, those 10 hundreds would be regrouped into 1,000. Now it works the same thing with, or the same way with decimals, in that once we have 10 thousandths, those 10 thousandths become 100. So it's kind of that same thing with decimal place value, that once the place value fills up to 10, remember, because our number system is the base 10 system, once it fills up to 10, it has to regroup, or we regroup to the next place value. So 10 thousandths would give us 100. Now let's talk about how we would express hundreds and thousandths as decimals. So this task says write 300ths, 3,000ths as a decimal. So the first thing we think about is that we know that 100th equals 10 thousandths. So if we have 300ths, as it says up here, 300ths, we know that is 30 thousandths. And if we have 300ths, 3,000ths, then we know that would be 33 thousandths. So to write that as a decimal, we could show that we have 300ths, 3,000ths, and so written it as a decimal would be 0.033. So if we look at these, finding the decimal that is represents the shaded part, well, here we have 1/100th, which we know equals 10 thousandths. And here's 100th, which again equals 10 thousandths. And then here we have 1, 2, 3, 4, looks like 5 thousandths to me. So we have 10, 20, 5, 25 thousandths, or written as a decimal would be 0.025. And you can see the 2 is in the hundredths place because we had 2 hundredths and, well, actually 20 hundredths, and then we had 5 thousandths. And let's look at another one. If we have 100th, we know that equals 10 thousandths. Here's another 100th. That's 10 thousandths. And one more 100th equals 10 thousandths. And then we have 1, 2, 3, 4, 5 thousandths. So that would be 10, 20, 35 thousandths. So written as a decimal would be 0.035. 300ths, or 30 thousandths, and 5 thousandths gives us 35 thousandths. Now, you can also express fractions as a decimal or show fractions as a decimal. So if we had 12 over 1,000, we would write that as 12 thousandths. So let's show that there are, or here it shows that there are 12 thousandths, but we know that 10 of those thousandths equals 100th. And so we can see that down in this place value chart. So now we have 100th, 2 thousandths. So written as a decimal would be 0.012. So looking at this number, if we were to read this number, remember whenever we see a decimal point, we say the word and. So we would read this number as 7 and 251 thousandths. 7 and 251 thousandths. So in this number, there are 7 ones, 2 tenths, 5 hundredths, and 1 thousandths. If we wanted to show this in expanded form with decimals, we would say 7 plus 0.2 plus 0.05 plus, think it in your head, 0.001. That's 1 thousandths. If we were to represent it in fractions as expanded form, it would be 7 plus 2 tenths, 5 hundredths, 1 thousandths. And I really like how this also breaks apart the place values for you to easily see the value of each digit. So if we look at the 5, the value of the digit 5 is 5 thousandths, and the value of the digit 1 is 100th, or 0.01, and the value of the 3 is 3 tenths, or 0.3, and the value of the 2 is 2 because it is in the ones place. And you can see that the decimal point separates the ones place from the tenth. And the last thing we're going to look at is expressing mixed numbers as decimals, which we kind of looked at already. But if we had this mixed number, remember a mixed number is a whole number and a fractional part. So if we have 2 and 372 thousandths, if we look at it on a place value chart, we can see that 2 ones, 3 tens, 7 hundredths, and 2 thousandths. So to write that as a decimal, remember anytime you see the decimal point, we're going to say the word and. And so 2 and, or 2.372 thousandths, 3 tenths, 2 700ths, and 2 thousandths. So let's put this into practice now. Let's work on turning these fractions or mixed numbers into decimals, remembering our place value is ones. The decimal point separates the ones place from the tenths, and then we have the hundredths and then the thousandths. So please practice writing these as decimals and then check back to see if your thinking matches mine. Okay, let's work through these. So number 15 would be 0.038, 38 thousandths. Number 17 was 2.103. Number 19 was 4.715. Number 21 is 1.001. Let's talk about this one for just a minute because many of you may have noticed that this was an improper fraction, right? The numerator was greater than the denominator. So we know that 1,000, 1,000th, right, would equal 1 whole, right? Anytime you have the same numerator and denominator, that's 1 whole. So that's where we got the 1 in the ones place. But we had this 1,000th left over, and that's how we got a 1 in the thousandths place. So the decimal would be 1.001. Number 16 was 0.287. Number 18 was 2.004. Number 20 was 3.050. And number 22, again, was one of those improper fractions. The numerator was greater than the denominator, and it was 4,972 over 1,000. So if here's 1,000 over 1,000, that would take 1 away, one of those 4,000s, another 1,000 over 1,000, another 1,000 over 1,000, and I'm going to squeeze in one more over here. So dealing with those 4,000s, those were actually represented 1 whole. So there's 1, 2, oops, my ones are getting bad here. But you get the idea. So that's where we get the 4 ones and then 972 thousandths were left over, so 4.972. So in this lesson, we reviewed what a tenth was and what it looked like, what a hundredth is and what it looks like. And we also really focused on thousandths today and what a thousandth looked like. We talked about how decimal place value is just like whole number place value, and that as soon as you get 10 in one place value, you have to regroup. So for example, 10 thousandths would regroup to, or be equivalent to, 100. We talked about how we can express fractions as decimals, and we also looked at how we can, how we can write mixed numbers as decimals. There's the mixed numbers.